All right, in this next section here, we're going to talk about how to find area of a sector. And we've done this before when we were back in our kind of perimeter and area circumference, like that unit where we kind of first started talking about how to do all of that stuff. So we have talked about how to find area of a sector before, but when we did that, we were working with the area of a sector in terms of degrees. And so I want to talk today about how do we handle it if we're dealing with radians, like we've been seeing the last couple of days, working with our radians measurements versus degrees. So if you kind of can remember, and you'll have to think back a little bit, when we had area of a sector, we had a formula where we had this theta. Remember, theta represented the angle that was in the sector, so in like the actual chunk of the circle that we were looking at. And it was times pi radius squared. And then that was all over 360. Okay, because back then we talked about how if I wanted to know like just how much this certain area of this specific piece was, I would take the angle divided by 360. So that's kind of what we're doing here. But because we've talked about radians, how many radians did we say was in a full circle, full 360 degrees? 2 pi, right? So I'm going to rewrite this a little bit so it says theta times pi times radius squared over 2 pi. Okay, because we can now convert from degrees to radians, okay, because we've talked about how a full circle is the same as 2 pi radians. And when you look at this now, you should probably be able to see there's some stuff that's in common from the top and from the bottom. What could we get rid of here? The pi's, right? Those go away. And so what are you left with? Theta radius squared all over 2. Good. So when that now switches to this theta radius squared over 2, it's a little bit simpler of a formula than what we dealt with before. But now instead of having degrees, like we're not going to put in 70 degrees or 60 degrees for theta. You could, right? You could have something in radians, convert it to degrees, put it into your formula. But instead, I'm just going to put in my radians in for that theta, and I'm going to work with it. Now, because this is already a fraction, it might be simpler if we almost think about pulling out the fractional part. And so rewriting this equation one more time as 1/2 times theta r squared. So maybe write this down because I think this is the form that we're going to want to use when we're finding area of our sectors today. You could do it in the original form before I rewrote it, but I think you'll see pretty quickly why maybe I wanted to do that, because most of the time when we're dealing with radians, it's written as a fraction already. And so if I'm putting a fraction in for theta here, you're going to have a fraction built into a fraction. It'd be kind of messy to deal with it that way. So instead, I'm going to just pull that 1/2 out front, and then I'm going to plug in my fraction next to it, and we'll just work with it like we were doing the other day when we were converting back and forth between degrees and radians. So if you just look at this first example that I have down here, I've got my formula up here I'm going to use. So I'm going to go ahead and write down area of this sector is going to be 1/2, okay, times, in for theta we put our angle, and this time it should be in radians instead of degrees. So what do they give me for my angle on the picture? Pi over 3, right? So we're going to put pi over 3 in for the theta. And then we have pi again. Oh, what did I, oh, you know what? I made a mistake up here. I put in an extra pi. I don't know why I did that. So get rid of that, and it should be r squared. I don't know why I snuck that extra pi in there. Sorry about that if that was confusing. So get rid of that pi from up here in our formula, so then I don't have an extra pi down here. So instead, I'm going to go straight to my radius now, which we said was how much? How much is the radius in the picture? 5. So I'm going to do times 5 squared. Okay, let's do a little bit of simplifying here. So across the top, and remember you can think of 5 as over 1 right now if you need to kind of see all the numerators and all the denominators. So across the top you have 1 times pi times 5 squared. What is 5 squared? 25. So I'm going to rewrite that as 25 pi. And then on the bottom, you have 2 times 3 times 1, which would be 6. Now, you could have reduced before you multiplied. When I was looking at those numbers, I just kind of knew I wasn't going to be able to put 2 or 3 and have that go into the 5 squared, which is 25. So I didn't worry about reducing. And so this would be your answer here. Now, the other thing that they might want you to do today is actually give us the decimal form, which means we're actually going to calculate with pi. Sometimes they might want you to leave it in pi. And if they do, like next to your answer, then they would put like that little E symbol, like they want an exact answer. If they don't want it in terms of pi, they won't have that little E, and they want you to just go ahead and round it to a decimal. So if you have a calculator, and if you don't, go grab one. But I want you to take 25 times pi, and you can use the pi button on your calculator, or you can just use 3.14 and then divide by 6. And let's round this to the nearest tenth. So go ahead and type that in. So this should come out to be about 13.1 if we round. And then we're still dealing with area here, so we have to label it, and this would be centimeters squared for area. Okay, so really either of these answers would probably be acceptable. It just depends on what form they want it in. If they want it in the exact form, then leave it as 25 pi over 6, and then you would say centimeters squared for that as well. If they want it as a decimal, then you have to go that extra step, actually multiply, okay, and get 13.1. All right, so hopefully you kind of followed that with using our new formula here and dealing with our radians. So we're going to kind of see some more examples down below, but they're going to kind of switch what they're maybe asking for, or maybe even what they're giving us. So down below, they're asking us to determine the measure of the missing variable, and they're giving us in parentheses, R stands for radius, D is for diameter, S is going to represent arc length, and then capital A is going to represent area. And so there's a couple different ways that they could maybe give you some information and want you to find whatever's missing. So let's work through these here together. So for part A, they are giving us the diameter of 4 centimeters, and they're giving me theta to be pi over 2. We're still thinking about that formula up above. Okay, so they're probably wanting us to just find area for this problem. So if you need to, you can write down your formula again at the top here. I'm just going to write this down like what we said above, which was 1/2 times theta r squared. Okay, the 1/2 is built in. I have my theta because they're telling me that's pi over 2. They aren't giving me the r though. What are they giving me instead? The diameter. What do we do to a diameter to get to a radius? Cut it in half, right? So what would be my radius here? Good, 2 centimeters. So make sure you pay attention to that, because if you put in the wrong number, you're going to get an answer that's too big. So now that I have my radius, I'm going to go ahead and plug it into my formula. So it's 1/2 times my theta, which is pi over 2, times my r squared. So 2 squared. Okay, if you even think about what this is going to look like, this is going to become a 4. What, can we do anything? Like, do you see anything? Like, what's going to happen with these 2's down here? They become a 4 as well, right? So really, these become a 4, and that crosses off with this 4. What are you left with? 1 times pi. Let's just write that as pi. We don't need to put the 1 there. And so this would still be area, is what we calculated there. And so what's my label? Good, centimeters squared. So pi centimeters squared would be my final answer here. Okay, so in that case, we were just finding area. We did have to work a little bit with the diameter. So just make sure you pay attention to that. They're going to sneak those kinds of things in periodically to make sure that you're paying attention. Okay, now let's take a look at letter B. B is giving us the area this time is 12 pi centimeters squared. They're giving me theta. It's pi over 6 radians. They want me to find r. So again, think about the formula that I wrote up here. Okay, we're still using this as kind of our baseline. So I'm trying to use this, but let's plug in what we know. They're giving me the capital A. What did they say the area was? 12 pi. So I'm going to put that in for capital A. Now my formula has a 1/2 built in. Can we put in anything for theta? Good, the pi over 6. And we're trying to find r, so we can't put anything in for the r squared. So we have to leave that there. Okay, I'm going to kind of clean this up a little bit. So I'm going to work more so with these two pieces for right now. So I'm going to rewrite this so it still says 12 pi. But then 1 times pi is pi here, and on the bottom now it's 12. And then I have r squared. Okay, I want to get the r squared by itself. So the first thing I would try to do is get rid of that fraction if I can. How do I get that 12 out of the denominator? Yeah, we're going to take this times 12. And we'll multiply this side by 12 as well. So when we do that, these 12s are gone. Okay, and so what I have now, we have to multiply over here. So we have 12 times 12 pi, which would be 144 pi. And then over on the other side, we have pi r squared. Okay, what would you guys do next? Again, my goal is still to get the r squared by itself. Good, divide by pi. What happens there? Yep, they're gone. So now I have 144 equals r squared. What's the last thing we need to do? Good, just square root. So what's my radius? 12, and what would be my label? Good, centimeters. Very nice. Okay, so that one requires a little bit more work, right? Because you're kind of working backwards. I would always encourage that you try to get rid of that fraction first, just because it tends to make it a little bit easier when you can get rid of the fractions, okay? And then you're just kind of taking it piece by piece. Now, some of you might be able to do some of those steps combined. Like you might start to be able to see ways to maybe solve that faster, okay? As long as you're getting the same answer at the very end, you should be fine. But if you're someone who's maybe prone to making silly mistakes because you go too fast or something, slow down and take it piece by piece, okay? Let's take a look at the last one here, letter C. Kind of similar in what we were given up above, in that they're giving us the area again. But this time, they're giving us the radius, and they want us to find theta. Okay, so again, here's our formula that we're working with. Area is equal to 1/2 times theta r squared. What are we plugging in for what? You guys tell me what we can put in where. Good, 40 pi can go in for the capital A. We've got the 1/2 still. What else can we plug in? Good, nothing for theta. And in for r, you can put 8. So it kind of looks like that. Okay, let's go ahead and clean this up a little bit. So I've got 40 pi. Now, what is 8 squared? 64. Okay, now maybe could we combine the 1/2 with the 64? Like, could we multiply those? What is half of 64? 32. So we've got 32, and then theta. How would you get your theta by itself? Yeah, divide by 32. These are gone. Now, can you reduce that? Because if I'm talking about radians, we want it in reduced form. What number could you take out of both 40 and 32? An 8. So if we take an 8 out of both of these, what does it become on top? Good, 5, and on the bottom, 4. Good. So you would have 5 pi over 4, and this would be radians. Make sure you reduce that. And again, if you don't know maybe what's a number that you could take out of both, you can always you could just type in 40 divided by 32 on your calculator and then hit that button. That'll switch it back to a fraction if it's giving you a decimal, and it should automatically reduce it for you. Okay? All right, that is it for notes. So I'm going to get you guys the homework, and you have the rest of the class period to work on this assignment. Make sure as you're working through it that you pay close attention to what are they giving you and what are they asking you for.